Hello dear students, this is Professor Anindya Das from Achievers and welcome to my lecture series on the second law of thermodynamics. In the present lecture, we'll deal with the series combination of engines. We'll deal with the series combination of engines and it's a very interesting topic. From here you can expect a lot of questions coming into your entrance or university examinations. So you must look very closely into this particular topic, the series combinations of an engine. Okay. So our present topic is series combination of engines. At first, we'll consider combination of two engines, then we'll consider combination of three engines, and then we'll generalize the facts. So, in case 1, we'll have a combination of two engines. E1 and E2. Let this temperature be T1, this be T2 and this be T3 in the order T1 greater than T2 greater than T3. Let Q1 amount of heat is withdrawn from the hot reservoir temperature T1 by the engine E1 and Q2 be released to the cold reservoir T2. Okay. Now let us consider that no heat gets accumulated into this reservoir so that again E2 will withdraw Q2 amount of heat from the reservoir temperature T2 and it will reject Q3 amount of heat to the reservoir at temperature T3. Here you have got W cyclic 1 and here you have got W cyclic 2. And we'll consider E1 and E2 to be Carnot engines. Carnot's engine means they are reversible engines. So they are reversible in nature. Okay. So we have combined two reversible engines E1 and E2 in this manner and we have considered no heat is getting accumulated in the reservoir at temperature T2. E1 is releasing Q2 amount of heat and that Q2 amount of heat is again being pulled by the engine E2. Okay. So no accumulation takes place over here. No accumulation. No accumulation of heat. Okay. So let us write down the fundamental equations at first. What are the fundamental equations? Fundamental equations. What are the fundamental equations? For E1, you have got mod W cyclic 1 to be equal to mod of Q1 minus mod of Q2. And for E1 you have got 1 minus mod Q2 by mod Q1 to be equal to 1 minus T2 by T1. This is the expression of eta 1. It's a reversible engine. So 1 minus mod QC by mod QH is 1 minus TC by TH. That's what I have written over here. And for E2 you have got mod W cyclic 2 to be equal to mod Q2 minus mod Q3. And you have got eta 2 to be equal to 1 minus mod Q3 by mod Q2 is equal to 1 minus T3 by T2. So this is equation number 1, this is equation number 2, this is equation number 3, and this is equation number 4. Okay. So far so good. We are already acquainted with all these forms from our previous lectures. Okay. Simple. Now, if we replace this by a single engine, if we replace this system, if we replace this combination by a single engine, then what will happen? I mean to say, if we replace this entire combination by a single engine, that is, I am connecting T1 and T3, I am connecting T1 and T3 by a single engine E, then what is going to happen? I am connecting T1 and T3 by a single engine. Then what is going to happen? Then E will be withdrawing Q1 amount of heat from T1 and will be rejecting Q3 amount of heat to T3. Okay. This entire combination has been replaced by a single engine E. Okay. So Q1 will be withdrawn and Q3 will be rejected. And this entire combination E1 and E2 is being replaced by a single engine E. And let the work be W cyclic. So for E, what do you have got? For E, you have got mod W cyclic to be equal to mod Q1 minus mod Q3. This is our equation number 5. And eta to be equal to 1 minus mod Q3 by mod Q1 equal to 1 minus T3 by T1. This is our equation number 6. So what you have got? You have got these two equations for E1, these two equations for E2, and these two equations for E. Okay. Simple. I think you all have understood the combination and the equations. Now, Our first question is, you have to express eta, that means efficiency of E, as a function of eta 1 and eta 2. That means you have to express the efficiency of E, the combined engine, with respect to the efficiencies of the component engines, that is E1 and E2. Okay. So you have to express the efficiency of the combined engine in terms of the efficiencies of the component engines. So how can we do that? See, it's very simple. Just you have to contemplate into these equations. You take equation 2, you take equation 4, and you take equation 6. Everything is going to be done. Okay. So at first, what we can write, T3 by T1 can be written as T2 by T1 multiplied by T3 by T2. We can write it in this way. You can always write T3 by T1 as T2 by T1 multiplied by T3 by T2. Now, what is the expression of T3 by T1? See, T3 by T1 is 1 minus eta. T3 by T1 is 1 minus eta. Using equation 6, T3 by T1 is 1 minus eta. T2 by T1 is 1 minus eta 1. And T3 by T2 is 1 minus eta 2. So, T3 by T1 is 1 minus eta. T2 by T1 is 1 minus eta 1. And T3 by T2 is 1 minus eta 2. Using 2, 4 and 6. Simple. So everything is done. So 1 minus eta is equal to 1 minus eta 2 minus eta 1 plus eta 1 eta 2. This 1 will get cancelled out and the expression of eta becomes, we take the negative sign there, so getting eta 1 plus eta 2 minus eta 1 eta 2. Okay. Simple. Very simple. Very simple. So I have done it. Now our next question, we will move on to the next question. Our next question is, you have to find out the expression of T2 in terms of T1 and T3. You have to find out the expression of T2 in terms of T1 and T3 under the two constraints. The first constraint is eta 1 equal to eta 2 and the second constraint is mod W cyclic 1 equal to mod W cyclic 2. For these two constraints, you have to express T2 in terms of T1 and T3. So this is our next question. So we'll do problem number A at first. 2A. Eta 1 is equal to eta 2. Eta 1 is equal to eta 2. Now what is the expression of eta 1? 1 minus T2 by T1. And what is the expression of eta 2? 1 minus T3 by T2. Let us equate them. 1 minus T2 by T1 equal to 1 minus T3 by T2 using 2 and 4. Simple. This 1 is going to get cancelled out, this minus will get cancelled out. So T2 square is T1 T3. So T2 is root over of T1 T3. It will not take plus minus because T2 is always positive. It's a Kelvin temperature. So it's always positive. It's always positive. It's never negative. So you see, under this constraint, eta 1 equal to eta 2, T2 is the geometric mean of T1 and T3. The intermediate reservoir has a temperature which is geometric mean of the upper and the lower reservoirs. Okay. Okay. So T2 is the geometric mean of T1 and T3. Done. Simple. Now we'll move on to problem 2b. Here you have got the constraint mod W cyclic 1 equal to mod W cyclic 2. What will happen in this case? What is going to happen in this case? Let's check. We are already acquainted with the expression of mod W cyclic 1 and mod W cyclic 2. Mod W cyclic 1 is Q1 minus Q2, mod Q1 minus mod Q2, and mod W cyclic 2 is mod Q2 minus mod Q3. So let us put that value. Mod Q1 minus mod Q2 equal to mod Q2 minus mod Q3. So mod Q1 plus mod Q3 equal to 2 mod Q2. Done. Now let us divide by mod Q1. Dividing by mod Q1. Let us divide all the terms by mod Q1. So it becomes 1 plus mod Q3 by mod Q1 equal to 2 mod Q2 by mod Q1. Simple. Now what is the expression of mod Q3 by mod Q1? You see. Mod Q3 by mod Q1, mod Q2 by mod Q1. So from here, from equation number 6, you can see, if you cancel this, mod Q3 by mod Q1 is T3 by T1. Mod Q3 by mod Q1 is T3 by T1. If you cancel this, mod Q3 by mod Q2 is T3 by T2. And if you cancel this, then mod Q2 by mod Q1 is T2 by T1. So mod Q2 by mod Q1 is T2 by T1. Mod Q3 by mod Q1 is T3 by T1. You just require this. So you are using equation 2 and equation 6. Using 2 and 6. In this case, we have used equation 1 and 3. Okay. See, if you multiply both sides by T1, then it becomes T1 plus T3 equal to 2T2. That means T2 is equal to T1 plus T3 by 2. So now, if mod W cyclic is equal to mod W cyclic 1 is equal to mod W cyclic 2, then the intermediate temperature becomes arithmetic mean of the upper and lower temperatures. So you see, if eta 1 is equal to eta 2, then T2 is the geometric mean of T1 and T3, And if mod W cyclic 1 is equal to mod W cyclic 2, then T2 is the arithmetic mean of T1 and T3. So under this case, T2 is the arithmetic mean of T1 and T3. T2 is the arithmetic mean of T1 and T3. T2 is the arithmetic mean of T1 and T3. Understood? Understood? Now, we'll move on to case 2. Where you have got three engines combined together. T1, T2, T3, T4. E1, E2, E3, they are connected. Okay. So here you have got three Carnot engines. You have got three Carnot engines. Q1, Q2, this is Q2, this is Q3, this is Q3, this is Q4. No accumulation. Same. This is W cyclic 1, this is W cyclic 2, this is W cyclic 3. Okay. And you can replace this by a single engine, T1 and T4, by engine E. It withdraws Q1, it releases Q4, and it has got W cyclic. Okay. So let us just write the expressions of eta 1, eta 2 and eta 3. Eta 1, eta 2, eta 3 and eta. Let us write all these expressions. Eta 1 is 1 minus mod Q2 by mod Q1 is equal to 1 minus T2 by T1. Eta 2 is 1 minus mod Q3 by mod Q2 equal to 1 minus T3 by T2. Then eta 3 is 1 minus mod Q4 by mod Q3 equal to 1 minus T4 by T3. Simple. And eta is 1 minus mod Q1 by mod Q4 equal to 1 minus T4 by T1. Okay. Simple. This can be written very easily. We are already acquainted with all these expressions. Now students, what we can do, we can write T4 by T1 as T4 by T3 multiplied by T3 by T2 multiplied by T2 by T1. We can always algebraically write in this way. Now what is the expression of T4 by T1? It's 1 minus eta. What is the expression of T4 by T3? It's 1 minus eta 3. What is the expression of T3 by T2? 1 minus eta 2. And what is the expression of T2 by T1? It's 1 minus eta 1. Okay. Now you have to simplify it. 1 minus eta is equal to 1 minus eta 3 multiplied by, we already know this product, 1 minus eta 1 multiplied by 1 minus eta 2. It's 1 minus eta 2 minus eta 1 plus eta 1 eta 2. So I've already got this. Now 1 minus eta becomes 1 minus eta 2 minus eta 1 plus eta 1 eta 2 minus eta 3 plus eta 3 eta 2 plus eta 3 eta 1 minus eta 1 eta 2 eta 3. Okay, simple multiplication. Simple multiplication. Simple algebraic laws of multiplication. You have to be careful a bit. Nothing else. Okay. Now this 1 will get cancelled out and you take minus sign. So you are getting eta to be equal to, eta 1 plus eta 2 plus eta 3 minus eta 1 eta 2 plus eta 2 eta 3 plus eta 3 eta 1 plus eta 1 eta 2 eta 3. So I've got this expression. So I've got this expression. Simple. Now what will be the result if we have n number of Carnot engines combined together? What will be the result if we have n number of engines combined together? I mean to say, the combination is E1, E2, E3, E4 up to En. Having efficiencies eta 1, eta 2, eta 3, eta 4 up to eta n. So what would be the expression of combined efficiency? What would be the expression of combined efficiency? Very easy. See, when n is equal to 2 and when n is equal to 3, you have already got the expressions. For n equal to 2, you have got, please focus into this expression, 1 minus eta equal to 1 minus eta 1 multiplied by 1 minus eta 2. 1 minus eta is equal to 1 minus eta 1 multiplied by 1 minus eta 2. For n equal to 3, what you have got? See, same. Just now we have done. See, 1 minus eta equal to 1 minus eta 1 multiplied by 1 minus eta 2 multiplied by 1 minus eta 3. 1 minus eta 1 multiplied by 1 minus eta 2 multiplied by 1 minus eta 3. So now you can create the series. Now you can create the series. So for n equal to n, 1 minus eta is basically a multiplication series pi I running from 1 to n, 1 minus eta I. As simple as that. As simple as that. It's a multiplication series. And this I ranges from 1 to n. So the expression of eta will become 1 minus pi I equal to 1 to n, 1 minus eta I. So this is going to be the expression of eta. This is going to be the expression of eta. Okay. So students, this is all about the concept of combined engines. Okay. So bye bye for now, and you keep on studying. We'll be soon back with our next lecture. Bye bye.